everything that we have graphed up to this point, well, as long as it's been a sine wave or a cosine wave, they have all had a period of 2 pi radians. Today, that's going to change. Now, this first example that they give us here is the parent function of sine. What I'm going to do is I'm going to write down what that pattern for sine is. It is very important for y'all to remember what these patterns are. All right, the pattern for a sine wave is middle, up, middle, down, middle. Once we get to this part of the pattern, we have completed a full sine wave. That usually takes 2 pi radians if we have no transformations, which we'll see today. That we'll see where today it affects the period in just one moment. Now, since this is the parent function of sine, your midline is going to be right on the x-axis. The amplitude, the number in front of sine, is 1. So go up 1 box above the blue line and 1 box below the blue line. Now, all of our patterns today are going to start on the y-axis. So then I would start here at the middle, go 2 boxes to the right, move up, 2 boxes to the right, back to the middle, 2 boxes to the right, move down, and then middle. And our coordinates should follow the pattern that I have written up here. Middle, up, middle, down, middle. And now we have the parent function of cosine. That pattern is up, middle, middle, up. Once we get to this portion of the pattern, we have now gone through a cosine wave. We are at 2 pi radians once you get to this part of the pattern. Now, this is the parent function of cosine. So midline's still going to be on the x-axis, and your top and bottom boundaries are going to be the same as the previous example. A reminder, all of our patterns today will start on the y-axis. So this time, follow the pattern. Start up the very top boundary. 2 boxes to the right, go middle. 2 boxes to the right, lower boundary. Make sure your dots follow the pattern. Up, middle, down, middle, up. And then connect. Now, I don't know if you've noticed this yet, but all of these graphs are missing some information compared to the previous graphs that we were given. They don't have the little hash marks here, there, there, or there. Previously, it gave them to us, and they also told us what the radians were at that point. Now, the reason why that we don't have them today is because not all of our functions are going to end at 2 pi radians. All the previous ones did. This hash mark previously was pi over 2, pi, 3 pi over 2, and then 2 pi, the cycle has been completed. So that's why they're missing today. We have to figure out, well, what are the new major points on the x-axis? Let's start with example 1. If you see something in front of x that we're multiplying 2x, this is 1/3 times x, that means we have a period change. Now, for right now, don't worry about the period change, because when we go to graph this on paper, you're not going to notice anything different than what we've been doing so far. If you'll notice, our midline in this example is still going through the x-axis. The amplitude is still 1. So far, that number in front of x hasn't changed anything. The pattern for this sine wave is still the same. We're still going to graph it the way we did the previous 2 examples. Follow the pattern, middle, up. And then connect. But when it comes to graphing these on paper, if we have a change in the period, not much really differs from the way we've been graphing up to this point. Now, here's where things do get a little bit different. If they were to ask you, what is the new period of this function? Here's how you find it. Take the number that is in front of x and set it equal to this formula right here. That's how we find what the new period is. Now I'm going to write 2 pi over x because my b's, they tend to look like 6s. And now I'm going to butterfly method. 1 times x is equal to 3 times 2 pi. X equals 6 pi. That's the new period of this function. What we did right here is the most important takeaway of what we're doing today. Now, I do want you to think a little bit, though. If a normal sine wave takes 2 pi radians to complete, and this one's going to take 6 pi radians, is it going to take a longer or shorter amount of time for this to complete its cycle? Longer, good. If the new period is greater than 2 pi, that means it's going to take longer for that function to complete its cycle. If the number is less than 2 pi, then that means it's going to complete its cycle much quicker. Okay, so we have already gone over what is the most important part of today's lesson. Can you identify what the new period is? I'm about to show you the least important part, the one I really don't want you stressing about too much, is because while it's not difficult, I suppose it can be a little confusing, and I truly don't even know if you're going to be tested over it. But you might. And if that's the case, I want you to have seen how it's done. What we now have to do is we have to figure out, well, what are our major points on the x-axis? We know what they were previously. What are they now? Now, this graph right here is way too small. So I drew the exact same graph here. That way I can make the x-intercepts, or at least the points on the x-axis that we want to stand out, make it a little bit more visible and a little bit more clear. Now, there's 2 points on this graph that we already know. We already know this point here. At this point on the x-axis, that's 0. And we know this one here. This is the very last point on your graph. We just solved for it. It's 6 pi. So here on your graph, you'd put 0. Here you'd put 6 pi. Now, the easiest x-intercept mark to come up with next would be this one here. The distance between 0 and 6 pi. That's just going to be 3 pi. To find the distance between any 2 numbers, add them together, divide by 2. Now that we know what these 2 numbers are, we can find the point in between them. 0 plus 3 pi is 3 pi. Divide by 2, we get 3 pi over 2. I would prefer you to not write your answers as decimals because we want to use fractions more times than not. The only time that you see an exception to that is if it says round to whatever decimal place. And now we can solve for this point, the distance between 3 pi and 6 pi. Add 3 pi to 6 pi, that's 9 pi. Divide by 2. Now, where could this come into play? Well, if you were asked to graph this new function and then list the x-intercept of these functions, now you know we have an x-intercept at 0, 3 pi, and 6 pi. So that's where you could see this. Yes. I don't know yet. I think it's safe to assume, based on the way things have been going, that it's probably going to be. That would be my guess. All right, let's take a look at example 2. We're dealing with a cosine wave here. Oops. That pattern for a cosine wave is right here. Up, middle. There is no vertical transformation here. Therefore, your midline is right on the x-axis. The amplitude is 2. So from that midline, that blue line there, go up 2 boxes and down 2 boxes. Now we're starting our pattern on the x-axis. We want to start at the top boundary, middle, lower, middle. up. Now, let's identify the new period here. That number in front of x. Set it equal to 2 pi over x or 2 pi over b. You can truly use whatever variable you want. 3 times x is equal to 2 pi times 1. It is 2 pi over 3. Good. That is the new period. What we just did here, reminder, is the most important takeaway today. And you identify what the new period is. Now what we're about to do next, remember, least important part. Don't worry about this too much. You probably won't even have to do it, but you might. I don't know yet. So here's that graph just a little bit bigger. We know what this point is. It's 0. This is where x equals 0 right there. And we know what the ending point is. It was 2 pi over 3. Now that we know what the starting point is and the ending point is, we can figure out what the midpoint is. Add these two together and divide by 2. But if you're dividing a fraction by 2, it's much easier to simply multiply the denominator by 2. It's the same thing. So if we do that, we get 2 pi over 6, which reduces 2 pi over 3. Now that we know these 2 points, we can find the distance between them. 0 plus pi over 3 is pi over 3. Divide by 2, or multiply the denominator by 2, we get pi over 6. Now we can find this one. Pi over 3 plus 2 pi over 3. 3 pi over 3, which is just pi, divide by 2. So if you were to be asked, what is the x-intercept of this function? It would be pi over 6 and pi over 2. Once you have this written down, here's what I want you to do. Turn the paper over, start working on example 3 on your own. Here's the only thing I want you to do, however. Graph it, and then tell me what the new period is. You don't have to worry about this part. So example 3, just graph it, tell me what the new period is. About 30 more seconds and I'm going to go over it. Whenever I'm graphing these functions, I like to begin with any sort of change in the midline and any phase shift, but we're not dealing with any phase shifts today. But we do have a vertical transformation, -1. So from the x-axis, go down 1. That's the new midline. Next, our amplitude. Is our amplitude -2 or +2? 2. Good, 2, just 2. Your amplitudes, sorry, they're always going to be positive. So from that blue line, go up 2 and down 2. Now you were not asked to do this one. You don't have to do example 4, but I'm going to write down the pattern for example 4. It's a sine wave, middle, up, middle, down, middle. This is a sine wave, but it is being reflected. So your arrows are going to change directions. Middle, down, middle. That's the pattern that we have to follow for this one. If you graph correctly, it should look like this. And now we're going to identify what is the new period. So take the number in front of x, set it equal to 2 pi over x. Four times x is equal to 2 pi. X equals pi over 2. Reminder, what I did just there is the most important takeaway of what we're doing today. Okay, the last thing that we're going to do together is we're going to look at example 5b. I'm about to show you the most common error with stuff like 5b. I'm going to start by actually writing down the wrong answer. I would not copy what I'm about to do. So y equals, we're dealing with a cosine wave, amplitude of 3, period of 7 pi over 4, vertical shift down 2, vertical reflection. Now, everything I just did is correct, except one thing, and it's the period. Great. Yeah, most students just think, okay, if it's the period of this, we'll just stick that in front of x. That's not the case. You have to figure out what value is going to produce 7 pi over 4 radians. So you're going to take the new period, 7 pi over 4, and set it equal to 2 pi over x, and then solve. Divide both sides by 7 pi. X equals, we don't really divide by pi very often, but just remember, if you're dividing anything by itself, they cancel. That's the number that I need to have in front of x. So I just simply need to go back to my answer, erase what I had in front of the x, and put 8 over 7. And now it's correct. That's the right answer. Please submit your notes on my Canvas page. We are on Unit 4, Day 3, and then get started on your Delta Math. If you need any help, let me know. Yes, sir. Go ahead. What is it? Okay, if it's a horizontal shift, then it would look something like x minus pi over 2.
There'll be a minus in that.
Yeah, let me just give you a quick example, like minus. Now we have a horizontal shift. Yes. Okay. Which today you're not going to have any of those. None of those today.